so yesterday we ended by coming up with that equation of I1 equals I2 plus I3. And then we saw the plot right at the end of class. And we labeled the slopes. How did I come up with 150 I3 for this slope? What's this a plot of? It is a plot of voltage. So 150, what's the 150 reference? The resistance of the resistor. What's the I3 reference? The current. Is there any relation? What does current times resistance equal? Voltage. So the voltage across the 100, there's some guy's name that's attached to that rule. No. Ohm's law. Oh, that's on like the top of page 24, right? So I know the voltage here. Now I could label that V. I could label it gobbledygook, anything I want. I chose to label it the resistance times the current. And the reason I did that is when I make an equation from the loop, I want to have the current in there. So I labeled all my slopes based on the information that I had, which is the currents, because I just did those in the previous step, and the resistances, because I had to have labels of voltage, and I used Ohm's law to say, well, V equals IR, so the voltage is the current times the resistance. And then I think we also went over yesterday that there's how many loops? 3 loops. 3 ways to go around the circuit and end at the same, start and stop at the same place and not cross my own path. Now, I could also, if it's easier, I find this plot, the change in height, looking at the change in height, to be the easiest way for me to make those 3 loop equations. You could also look at it like this, get rid of the 3-dimensional plot, and with the labels of the voltages across these things, realize that anytime I go with current and I go across a resistor, it's like going down. And anytime I go with a battery, across the battery in the direction of current, it's like going up. And then if I go against current, all of those are reversed. You could do it from that, or I prefer to see it as ups and downs, but it's completely personal preference. All right? So which diagram do you guys want to use to create the 3 loop equations that you attempted for homework? This one? All right. So there are 3 loops. There are 3 ways to start and stop at the same point and not cross my own path that are unique. And each of them is going to generate a unique equation. Now, it doesn't matter where you start as long as you stop at that point. But I don't recommend starting like halfway up a slope. That just becomes confusing. So I would suggest starting on a flat portion. And just by preference, I'm going to start my first loop right here, just because it's nice and close to where I'm standing. And I'm going to go from here. I'm going to go around. And I'll go across the 150. And then I keep going around and I get back to where I started. Did I cross my own path at all? Did I end up where I started? So that's a valid loop. What that loop does, what Kirchhoff told us about that loop, is that if I add up all the voltage changes, all the energy changes around that loop, I'm going to end up with a value of 0. So what I like to do is I trace it. This is why I think I like this diagram so much. is I trace my loop, and as I hit the elements, I put in the mathematical terms for those into that idea that if I add them all up, I'm going to end up with the number 0. If I go down a slope, it's a negative, I put in a negative term. If I go up a slope, I put in a positive term. So as I'm going around my blue line here, I go down across the 150 I3, so I put in negative 150 I3. I continue along, and I hit another downslope across the 40, so it's minus 40 I1. Continue around, I go up 6 over the battery, so plus 6, and I get back to where I started, so that all equals 0. Questions on how I got any of those terms, or the positives and the negatives? All right. Where should I start for my second loop? Okay. Should I go clockwise or counterclockwise? Can you tell that it's arbitrary? So you guys pick. See, it shows that you're invested and involved. Clockwise. Okay, so clockwise. So I'm going to go this direction. So I'm going to go here and down here, up to 40, and then transfer over, go up to 100, keep coming around, and get back to where I started. So now remember, oh, when I go across the battery, is that going to be a positive or negative term? When I go down that slope, negative, so negative 6, up over the 40, so plus 40 I1, up over the 100, so plus 100 I2, and then I get back to where I started, so equals 0. And then now I need to do, now, how many unknowns do we have in these 3 equations? How many variables? Count again. 3 variables. We have I1, which is a variable, I2, and I3. If I have 3 equations and 3 unknowns, is it possible to solve it? Yes. So I could actually stop generating equations right here, because I have enough equations theoretically to solve my unknowns, solve for my unknowns. And I have at least one junction and at least one loop equation, so I think things are going to go well in being able to solve all the information that I want for the circuit. I'm going to suggest, at least in the beginning, you try to make equations for all of the possible loops so you get better at it. Good practice. So the loop that we haven't done is the loop just around the parallel section of the circuit here, the one I've circled in black. I know it's a little hard to see. But if you didn't do this one, you'd still be able to mathematically solve this. So let's see. I'm going to start right here. And I'll go up over the 150, so I get 150 I3, come around, go down over the 100, so minus 100 I2, and I'm back where I started, so it's equal 0. Any questions about how we got any of those 4 equations? All right, so now all you have to do is solve them. Right? Just algebra. Wait a minute. Which class is this? Oh, it's not algebra class. So do I share how you solve these? I care, here's the physics, getting these and then being able to get values from them. In math, we care, hey, how do you solve those? What I'm going to suggest to you is if you go up to our website, down here at the bottom of it, there are 3 solvers. Quick Math, this WIMS linear solver, and Wolfram Alpha. If you put these equations in any of these, it will do the work, the mathematics for you. One suggestion I'm going to make, though, is that rather than using the I1, I2, I3, that you use regular alphanumeric characters like A, B, C. Avoid E and avoid I, because E and I have special meanings, right? So I would suggest rather than having I1 equals I2 plus I3, you have like A equals B plus C. And therefore, then you have minus 150 C minus 40 A plus 6 equals 0. Minus 6 plus 40 A plus 100 B equals 0. And 150 C minus 100 B equals 0. You can also do these on your calculator. You can put them in. You can also convert them to coefficient and variable matrices and do matrix math on them. There's a lot of ways to solve those. So pick your method. You can also do it by hand. Doing this one by hand, you would do some substitution and things like that. So give it a try. See it. Can you find out values for these 3 currents, A, B, and C? All right, pick your favorite solver and go for it. We'll come back together and see what you get and see what I get. So those are the values that the solver kicked out. So I1 is 60 milliamps, I2 is 36 milliamps, and I3 is 24 milliamps. And you can see by those numbers why I'm asking you to use milliamps rather than amps. Just makes nicer numbers, easier rounding. So you can be more consistent in your notation. So then you get down here to this bottom table that you need to fill out. Which current was it that went through the 150 ohm resistor? I2. So that's, are you sure? It's always good to make sure you know. Well, maybe yours was I2. I think mine was I3. Because if I look at I2, I know it's either I2 or I3, and 150 is bigger than 100, so it's going to have less current. Right? Because electrons are lazy. They don't want to go through the big one. So less are going to go through. So for me, it was I3. And through the 100 was I2. Through the 40, oh, that was I1. What current went through the battery? Let's take a look. This is where these can be very helpful. I'm going to actually flip to the next slide. Which of my currents went through the battery? I1, right? I1 went through the battery. So that means that was 60 milliamps. So I know the resistances because those are given. I just found all the currents. How can I find the voltages? Wish there was some way to relate resistance, current, and voltage. Ohm's law. The one equation that we have. Don't worry, we'll get others, but for right now. So let's see. But would Ohm's law work for the battery? Does the battery have a resistance? Oh, we know the battery. Good point. I can just write that one right in, right? So, how many volts is across the 100 ohm resistor, let's say? $3,600 what? Now, there's a good thing. What's the maximum voltage anything in this circuit could have across it? 6 volts. So if you ever get an answer bigger than 6 volts when calculating the voltage in the circuit, you should say, oh, wait a minute, maybe I did something wrong. So it would be 3.6. Right. What about across 150? I think some of you are struggling with Ohm's law. V equals IR. So the I you take, and then the R, and you multiply those together to find the V. So no. Well, wait a minute. That's what we got across the 100. How can we have the same answer again? Because they're in parallel. So wait a minute. So I just confirmed that these numbers are probably right because they came up to be the same. Wow. What about the 40? That'd be a good way to check it, right? The 40 plus either one of these should add up to 6, right? So I'm expecting 6 minus 2. I'm expecting 2.4. Do I get that if I do Ohm's law? Yeah. Wow. You mean I can be really confident in these numbers because they actually also make sense with our rules, which is kind of nice. And the way you would check these is we'd go back to the simulation and we put a voltmeter over them. So let's see if it doesn't come out to be 3.6. It does. All right. And this, in this part, we'll work with the virtual circuit. Our delta, when we get there, you're going to actually physically build the circuits, take out a physical voltmeter, and check that your answers are correct by measuring the voltage. Do it physically rather than virtually. But I could put that voltmeter on each one of these and check, and guess what? The answers would be correct. They would be consistent. All right? So, we're ready to go to part B, where you have another circuit. Can you, at the bottom of page 28, can you write in pause and check? Because what I'd like you to do is go through 1 and 2, and then pause and check with either the class or with another group before you go on to using 1 and 2 to create your equation. All right? But we'll check your values after we get all the way through. So start working on 1 and 2. Work with your partner, not alone. All right? And then as a class, or as if a couple of groups are done, I don't want to hold them back, we'll check 1 and 2 together before you move on to using that information. All right? So most people said they came up with 4. I came up with 4. I labeled them like that. many junctions? What do you say, Justin? 2 junctions. Yep. There's one here and one here. So how many unique junction equations are you going to get out? If there are 2 junctions, how many unique junction equations are you going to get? Remember, this is a special case. 1. Because if you had 3 junctions, you get 3 equations. 4, 5, 5, 6, 6, so on and so forth. But with 2, you're going to get the same equation twice. So you should have 1 junction equation with those 4 currents. So here's how I plotted it. I know that back here at the negative side of the battery, it's at 0. So that means up here in the front of the battery, it's at the positive side, it's at 12. It's got to go down a little bit over the 20. So from the 20 till it hits the 3 resistors, it's going to be slightly less than 12. And then between the 75 and the 15, needs to go down a little bit, but not all the way down to 0. And then I connected all my slopes like that. All my flats. So hopefully yours was something reminiscent of that. And if not, you should look at it and say, okay, what did I need to do differently so that I can be successful in the future? Huh? I am recording. Would you rather I stop recording so you can make a comment? Yeah, as soon as I flip into the PowerPoint, it stopped. It's underneath. And then, of course, I labeled my slopes thusly. All right, using that tricky conniver Ohm's law. And remember, if it's easier for you to see, you could always set it up like that. It wouldn't count it, give you credit for the plot, but it might help you set up your loops easier. So the next question you should be asking yourself and your partner is, how many different loops are there? I'll solicit that answer in a little while. Let you think. On. I hear 6. I heard 7. Loop 6. Allie, what did you guys come up with? Are you still working on it? 4. Yeah. What about you guys? 4. There are 6 loops. So you should be able to create 7 equations. 1 junction equation and 6 loop equations. What we're going to do is have people put those on the board before our next thing. All right, so those on the whiteboard here are the 7 equations that you should have as homework tonight. Solve those and come up with what your predictions are for part B. So use the linear solvers, do it by hand, use your calculator, however, come up with on the bottom of 29, fill in this chart for homework. All right? Alec will translate his writing for you. It is correct from as much as I can read his writing, but he's the expert at it.